Hi everybody, this is an answer key for the Trig Lesson 6 homework. Let's get my calculator ready. Okay, and so we'll start with number 1 here. It says two office towers are 30 meters apart. From the top of the shorter tower, the angle of elevation to the top of the other tower, which is 250 meters high, is 70 degrees. Okay, so you can see that in the diagram. How much taller is the taller tower? Okay, so the amount taller is this little blue line right here, which we can call x. And since the buildings are 30 meters apart, that 30 can transfer up to here. It's going to be hard for me to write that in, but I guess I can put that as 30 meters. And we'll use the 70 degrees, which is right here, and then label the triangle based on that. So across from the 70 is the opposite side. We know this will be the 90, and across from the 90 is the hypotenuse. So this 30 must be the adjacent. So we have the adjacent, and we are looking for the opposite. If we again write down SOHCAHTOA, we are looking for opposite, and we have adjacent. That's going to come from tan. Awesome, so we would go tan 70 degrees is equal to the opposite is x, the adjacent is 30. Okay, and to get x by itself, multiply both sides by 30. So x is equal to 30 times tan 70 degrees. And let's do a quick check that we are in degree mode. Good. 30, tan, 70. And we get 82.4 meters taller. Okay, and that is consistent with the answer key. Okay, so part B, determine the height of the shorter tower. So now what we can do is, if we want to erase some of this stuff, we just figured out that this length right here is 82.4 meters. That's how much taller the taller tower is. So if I go 250 minus the 82.4, that will give me the height of the shorter tower. So I would go 250 meters minus the 82.4, and we get 167.6. Okay, that's what this length would be, which, like, from this dot right here down to here, and that matches up with this side over here, so 167.6. Okay, and so that is good in the answer key. And finally, determine the angle of depression to the base of the taller tower from the top of the shorter tower. So from the top of the shorter tower right here, remember the angle of depression goes down from the horizontal line. So imagine a horizontal line like that. The angle of depression is there to that dotted line, which is looking right at the base of the taller tower. So that's the angle that we want to find right in here. Let's call it, maybe we could call it alpha. And we know that right across is the opposite side, so this 167 is the opposite. And we knew that since the buildings were 30 meters apart, that this little length right up here was 30 meters. And there's the 90 degrees. So the dotted line over here is the hypotenuse. So the 30 must be the adjacent. Okay, so we've got the adjacent, which is 30, and we've got the opposite, which is 167.6. So you go tan theta equals opposite over adjacent, and we are ready to solve for alpha. You do tan inverse of 167.6 divided by 30. Shift tan 167.6 divided by 30, close that, and press enter. So 79.85 degrees. And if you go to the nearest degree, that would be 80 degrees. Okay, I'm going to do a quick pause here so I can shut my window. There's some noise coming in from outside. Alright, hey everybody, I am back. Okay, let's check out number 2. A man on the mast of a boat measures the angle of elevation to the top of a waterfall as 38 degrees, angle of elevation up to the top, and the angle of depression to the bottom of the waterfall as 18 degrees, so the angle down from the horizontal to the bottom of the waterfall. If he is 180 meters away, find the height of the waterfall. Okay, so this is an addition question because we have to find this length x from sort of that middle point up to here, and we have to find this length y from kind of the middle to the bottom, and then we're going to add x and y together. Okay, so in the top triangle, across from the 90 is the hypotenuse. Across from the 38 is the opposite. We're looking for that. So this must be adjacent. So looking for opposite, and we have adjacent. That is tan. So tan of 38 degrees is equal to opposite divided by adjacent. And that's from SOHCAHTOA in a 90-degree triangle. All right, so then multiply both sides by 180. And we get x equals 180 times tan 38. And we get 140.6. And we just found a side length x, so that's going to be in meters. And now in the bottom triangle, across from the 18 is the opposite, and the 90 degree would be there, so this is the hypotenuse, so the 180 is adjacent again. So I would go tan of 18 degrees is equal to y over 180. And multiply both sides by 180 again. And we get y equals 180, 180, tan 18, bang, 58.5. And then we can say, therefore, the height of the waterfall is equal to x plus y. So I would go 140.6 meters plus 58.5 meters. 140.6 plus 58.5, and that gives us 199.1. Okay, which is what they have in the answer key. Great. Okay, so the height of the waterfall is that. Nice. Okay, number 3. Two cabins, A and C, are located a distance apart on the bank of a river. On the other side of the river from the two cabins is a boathouse. Okay, so this is the boathouse over here. Boathouse B. It is 420 meters from cabin C, okay, as shown in the diagram, to the boathouse, and the angle at cabin C between the boathouse and cabin A is 15 degrees. From cabin A, the angle between cabin C and the boathouse is 70 degrees. Determine X, first of all. Okay, so we're going to have to use this triangle on the left because we know that side and an angle in there. 15 to be able to get X. Okay, so based on the 15-degree angle, label the triangle. This would be the opposite side. Across from the 90 is the hypotenuse. Okay, so we want the opposite and we have the hypotenuse, so that is going to be sine. Opposite and hypotenuse. So I would go sine of 15 degrees is equal to X divided by 420. And multiply both sides by 420 to get our answer for X. X is equal to 420 times sine 15, which is 108.7. And that is going to be in meters. Okay, part B says, how far is cabin A from the boathouse? Okay, so they want us to figure out this y distance here. We've now figured out that x is 108.7, so I'm going to erase this and I'm going to go 108.7 meters here, and we'll use the 70 degrees that they gave us. And so across from the 70, this is the opposite side. Okay, so we have this side, the opposite, and there's the 90 degrees. Across from the 90 is the hypotenuse. So this is the hypotenuse. So we're looking for the hypotenuse and we have the opposite. Okay, so that's going to be sine again. So I would go sine of 70 degrees is equal to, the opposite is 108.7 divided by the hypotenuse y. And remember, when you have the equation like this, those end up switching spots. So we'll end up getting y equals 108.7 divided by sine 70 degrees. Okay, and we get 115.7 if we round to one decimal place, and that's going to be in meters because this was in meters. And part C, how far apart are the cabins? Okay, so the cabins are at A and C, so we have to find this whole distance. We're going to have to split it up into this piece, which we could call M, and then the next piece, N, just so we're not using X and Y again. Okay, and there's a number of ways that we can do this. In the triangle here on the left, let's do this. Well, across from the 15, that's still going to be the opposite. Across from the 90 is the hypotenuse. So the m is actually the adjacent. We don't really need to do anything too crazy. So we're trying to find m, the adjacent, and why don't we use the hypotenuse, because that was a nice exact, 420. So adjacent and hypotenuse is going to be cos, so I would go like this. Cos of 15 degrees equals m adjacent divided by that 420, and then multiply both sides by 420. And we get m is equal to 420 times cos 15, which is 405.7. That's going to be meters. And now let's go and figure out n, which is here, and 70 across from the 70 is the opposite. We know across from the 90 is the hypotenuse, so this is going to be the adjacent. And both of the figures in here, x and y, those are rounded to one decimal place, so it doesn't matter which one you use. How about we use the 108.7, which is the opposite side. So we have the opposite, and we are looking for the adjacent, so that's going to be tan. The angle was 70 degrees. The opposite is 108.7, and the adjacent is n. Okay, in this case, those end up switching. .7 divided by tan 70, ding, 39.6. And yeah, I don't want to circle this one because that's not a final answer. So how far apart are the cabins? So the distance between the cabins is equal to m plus n, which is 405.7 meters plus 39.6 meters. Which is 445.3. Okay, the answer key says 445.7. They may have used this 115 here instead, in which case, if you've got the hypotenuse and you're looking for adjacent, it would be cos 70 equals adjacent over the 115.7. This would actually be 115.7 times cos 70. So that's what they would get. And then add that to the 405.7. Which is the same. Okay, so my only guess is that perhaps they didn't use rounded values to get those two. Okay, not a huge deal though. Okay, let's get on to number 4. A helicopter hovers above a tower if the angle of elevation from an observer 270 meters away to the helicopter is 62 degrees. Okay, so they're saying this whole angle is 62 degrees, like that. And the angle of elevation to the top of the building is 48 degrees. Find the height the helicopter is above the tower. Okay, so they want us to find the height that the helicopter is above the tower, so that h. Okay. Okay, so here's the plan of attack. This is where our 90-degree angle would be, and we have two 90-degree triangles. The big one that goes all the way out here, and then there's this smaller one. Okay, and so the plan of attack is to use the big triangle to find the whole height up to the helicopter, and then use the smaller triangle to find from here to here. And when I subtract those two lengths, then it shouldn't leave me this small little piece. Okay, so if I take like the whole height and I subtract off the height of the building, the tower, it should leave me the height that the helicopter is above the tower. Okay, so why don't we call this one y and this one x? So it essentially comes down to this. (62 degrees), we've got y all the way up to the helicopter, and this is 270 meters. And then the other situation is this, 48 degrees, 270 meters, and then this is x. So this is to the top of building. Okay, and then the difference between y and x will be the height that the helicopter is. Okay, so this is the helicopter right here. This is top of tower. Okay, and so if we go y minus x, we would get that height h the helicopter is above the tower. Okay, so let's figure out y. Across from the 62 is the opposite. This is the hypotenuse, so this will be adjacent. Looking for opposite, have adjacent, so it's going to be tan of 62 degrees equals y over 270 multiplied by 270 multiplied by 270. Y is equal to 270 tan 62, bang, 507.8 meters. That's how high the helicopter is off the ground. And then over here, we have opposite. This is adjacent. This is hypotenuse. So we're looking for opposite. We have adjacent, and we would go tan of 48 degrees equals x over 270 multiplied by 270 multiplied by 270. 270 tan 48, 299.9. Okay, so we know that this is the height of helicopter from the ground, and we know that this now is the height of the tower, and we can say therefore height helicopter is above tower equals 507.8 meters minus 299.9 meters. $207.9 meters. Wow, bang on in the answer key. All right, number 5. Olivia looks out the window of her apartment building and sees a Corvette down the street at an angle of depression of 18 degrees. 18 degrees to the lower line, so this is the Corvette. A little farther down the street, she sees a police car at an angle of depression of 15 degrees. Her apartment window is 35 meters above street level. How far apart are the Corvette and police car? Okay, so they want us to figure out X right there. So that's the Corvette, and that's the police car. Okay, so this is going to be a subtraction question. The plan of attack is this, guys. We are going to find the length of the big triangle from here all the way to the police car. And then we will find the length of the smaller triangle side from here to the Corvette. And hopefully you guys will agree that if I subtract these two lines, if I go the blue one minus the red one, it will leave me this small little piece right here, which is X. Okay, so to get this big blue line right here, we actually need this angle from here all the way to that second dotted line. Okay, so that we're using this big triangle right here. Okay, so we're then going to figure out that whole big length right there, which corresponds to this blue line down here. So we can call that Y we're trying to find. Okay, so we've got 35 meters in that triangle. There's the 90. Okay, and we went to kind of the upper dotted line, and it's saying that this is 15 degrees right here. And remember, the whole angle is going to be 90 from the dotted line to the building. And so 90 minus 15 is going to give us this angle of 75 degrees that we need. Okay, and across, this is going to be the opposite side. That's what we're looking for. That's Y. And across from the 90 is the hypotenuse. So this is the adjacent. So we're going to be dealing with opposite and adjacent, so that's tan. So tan of 75 degrees is equal to Y over 35. And then multiply both sides by 35. 35 tan 75. And we get our Y length of being 130.6. Oops. Okay, so Y is 130.6 meters. And now we have to get the red line, so I'm going to erase all of this stuff. Okay, and so now we have to figure out this distance here, which we could call Z. Put it down here. And we're going to use the smaller triangle this time. So right along here. Here's our 90 degrees. And so if it's 18 degrees down to there, and the whole thing is 90. This is 90, right? We'd have to go 90 minus 18 to get our angle in the corner there. 90 minus 18 is 72 degrees this time, like that. Okay, so across from the 72, this is the opposite. That's what we're trying to find. Across from the 90, this is going to be the hypotenuse, so again, this is adjacent. Working with opposite and adjacent, we would go tan of 72 degrees is equal to z over 35, and multiply both sides by 35. So z is equal to 35. Tan 72, 107.7 meters. And we can say, therefore, x, the distance between the Corvette and the police car, is equal to the whole big y distance, the blue line, minus the z. Y is 130.6, take away z, 107.7, and we get 22.9 meters. Okay, again, consistent with the answer key. All right, number 6. For the gorge in the diagram, calculate the width of the gorge. Okay, so to do that, we've got this 90-degree triangle. 27 degrees there, so this is the opposite side that we're trying to find. Across from the 90 is the hypotenuse, so this 63 must be adjacent. And again, SOHCAHTOA, which one deals with opposite and adjacent? That's tan. So we would go tan of 27 degrees equals, the opposite is W, the adjacent is 63. Multiply both sides by 63. 63, tan, 27, bang, 32.1. What is that? Meters. And find the depth of the gorge. The depth is right here. Across from the 37, that is the opposite side. That's what we want to find. This is the hypotenuse. So we're going to have to use that W that we found. And what is it? 32.1. And that's going to be the adjacent side. Okay, so again, we're working with opposite and adjacent. So we would have to go tan of 37 degrees equals, the opposite is D, the adjacent is 32.1, and multiply both sides by 32.1. D is 32.1, tan 37, bang, 24.2. All right, number 7 says, from the top of a 100-meter tower, a fire ranger spots 2 fires. One fire is due east, of the tower at an angle of depression of 16 degrees. The other is due west and has an angle of depression of 23 degrees. Calculate the distance between the fires. Okay, so what we have to do is figure out this x distance from here to here, and this y distance from here to here, and add them together. Our 90-degree angles are here. We have to figure out angles inside the triangles, so right here and right here. And remember, this is 90 and this is 90, so we're going to go 90 minus 23 to get this angle, which will be 67 degrees. And to get this angle, we would go 90 minus 16, which is 74 degrees. Perfect. Now, in this triangle on the left, across from the angle is the opposite side. Across from the 90 is the hypotenuse. So this 100 must be the adjacent. So katoa, we are looking for opposite, and we have adjacent, so tan. So I would go tan 67 degrees is equal to opposite is x, adjacent is 100 meters, and multiply both sides by 100. So x is equal to 100 tan 67, which is 235.6. And in the other triangle, across from the 74 is the opposite. Across from the 90 is the hypotenuse, so the 100 is the adjacent again. Opposite and adjacent, so it will be 10. 74 degrees equals the opposite is y. The adjacent is 100. Multiply both sides by 100, and y equals 100 tan 74, and we get 348.7. I'm just going to pause for a second because there is a fair bit of noise again. Okay, I'm back. So the distance between the fires is x plus y. It's equal to, yes, x plus y, which is equal to, let's add those together, 235.6 plus 348.7, 584.3 meters. Perfect, we're down to our last two questions here. Let's get on to number 8. From a point on the west bank of a river 2 kilometers wide, so this point right here, 2 speedboats leave for their respective cabins on the east side of the river. The distance to the closer cabin is 3.5 kilometers, and the distance to the further cabin is 4.2 kilometers. What is the measure of the angle between the boats' paths? Okay, so one boat goes off like that, and the other boat goes off like that. And so we want the whole big angle. It's made up of angle alpha and beta. So we have to find two angles and add them together. So in the top triangle, angle alpha, across from it is the opposite side. These are the 90s here. Across from the 90 is hypotenuse. So that's a hypotenuse, and leaving the 2 kilometers to be the adjacent. So we are going to be working with adjacent and hypotenuse. So katoa. Which one deals with adjacent and hypotenuse? That would be cos. So I would say cos of alpha is equal to, the adjacent is 2, the hypotenuse is 3.5. And so alpha is equal to cos inverse of that ratio. Just make sure you're in degree mode. Good. So we would go second function cos 2 divided by 3.5. 55 degrees. So there's alpha. And then with beta, across from beta, this is the opposite. Across from the 90 is the hypotenuse. So that's the hypotenuse, and the 2 kilometers is adjacent again. Adjacent and hypotenuse, it's cos again. So you would go cos of beta equals, the adjacent is 2, the hypotenuse is 4.2. So beta is cos inverse of that. Shift cos 2 divided by 4.2, 62 degrees. Okay, so therefore we can say angle between the boats is equal to alpha plus beta, 55 plus 62, and that's where we get the 117 degrees from that they have in the answer key. All right, and finally, number 9. A chairlift on a ski hill is constructed as shown below. Okay, lower terminal to ski lodge and then upper terminal. What is the elevation of the upper terminal? Hint, you'll need to find at least 3 missing pieces. Okay. So the elevation of the upper terminal, guys, is how high it is off the ground, so to speak. So we want to figure out this h, this elevation. And you'll notice that it's made up of this x length right here and that y length. So we have to figure out x and y and add them together. Okay, now that x will translate over here. This will be x. Okay, and we know a side and an angle in that triangle where x is now, so it would be easy enough to get x. Okay. But in order to get y, we are going to need one of the other sides in the triangle that y is in. Okay, we're actually going to need this side. We need to somehow get the bottom side here, and then it translates up to there. All right. And so the way to get this piece actually right here, guys, is we're going to have to, again, work in this triangle and get this piece here. And since we know that the whole length on the bottom is 2,000, we'll have to go 2,000 minus this one, let's call it Z, to figure out this guy over here called V. And then that will go up there. And then we'll use those 2 pieces of information to get Y. So that's the plan of attack. Okay, so let's first figure out X. Using the 21 degrees, X is the opposite. There's the 90. Across from the 90 is the hypotenuse. Opposite and hypotenuse comes from sine. So sine of 21 degrees is going to equal X over 1200. And then multiply both sides by 1200. And so X is going to equal 1200 times sine 21, which is 430. Okay, Okay, and notice that that's going to actually stay as 0.0, right? So there's x. So that means this is 430, and this is 430. Okay, so now we have to get y, and then we'll add x and y to get the h. Okay, the elevation of the upper terminal. Okay, so we are going to need to figure out z first, which will then help us get this one here, which I could call v. Okay, so in this triangle with the 21 degrees, that's still opposite, that's hypotenuse. Z is adjacent. So if we're looking for adjacent and we have the hypotenuse, that's going to be cos. So I would go cos of 21 degrees equals the adjacent z over the hypotenuse 1200 and multiply by 1200 again. So z is equal to 1200 cos 21, and we get 1120.3. So now I'm going to erase this. Say that this is 1120.3 meters. Okay, so that's 1120.3. The whole thing is 2,000, so we can say therefore V is equal to 2,000 meters minus the 1120.3 meters. Okay, and we get 879.7. Okay, so that's what this is, and since that's a rectangle, this is 879.7, and now we can use this 27 degrees and the 879.7 to get y. So across from the 27 degrees, this is the opposite side. Across from the 90 is the hypotenuse. So this 879 business is the adjacent. So I'm going to be working with opposite and adjacent, so that's tan. Tan of 27 degrees equals opposite y over adjacent 879.7, and then multiply both sides by 879.7. And we will get y equals 879.7 times tan 27. We get 448.2 meters. Good. We have x and we have y, and therefore we can say the elevation of upper terminal is equal to h, which is x plus y, which is equal to, let's just add those together. X is 430, y is 448.2, and we get 878.2 meters. Hey, look at D, 878.2. Okay, they went to 2 decimal places. I probably should have done that throughout. But anyway, there's D. Okay, so there's an answer key for Trig Lesson 6 homework, everyone. And again, I'll talk to you soon.